Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're talking about acid nomenclature. We need to be able to recognize acids, and then we're going to learn to write names and formulas for acids. So the first step is really recognizing that the compound you're working with is an acid. And at this point in the year, I want you to know that we can identify acids because they contain hydrogen ions as the cation. Now, there's more to it than that, but for now, this will work. And we name them as acids when these compounds are dissolved in water, and we would write a little AQ after the symbol to indicate that. So, for example, HCl, when it's dissolved in water, is an acid. We call it hydrochloric acid. You may know it as stomach acid. H2SO4 is another common acid. Notice we've got H plus ions as the cation, and this is battery acid when it's dissolved in water. And acetic acid is another common acid, commonly known as vinegar. The other thing I wanted to point out here on this slide was that these are all neutral formulas. So chloride has a -1 ion. I need 1 H plus ion. Sulfate has a -2 charge. I need 2 H plus ions. Acetate has a -1 charge. I need 1 H plus ion. But the other thing with that acetate formula is it's got the acidic hydrogen, and then it's got other hydrogens in the formula. Just because hydrogen's in the formula of a compound doesn't make it an acid. We're writing it like it's an ionic compound, and we've got H plus as the cation. It's only these first hydrogens in the formulas, the ones that I've circled here, that are the acidic hydrogens. Just having hydrogens not enough. Now we can categorize acids in a couple of different ways. One type of acid is referred to as a binary acid. And when I say a binary acid, what I mean is that the anion of the acid does not contain oxygen. For example, HCl is a binary acid. HBr is a binary acid. H2S is a binary acid. All right. And when we have a binary acid, that gives us a particular set of rules for naming them. So when you have one of these binary acids, here's how you name them. You use the prefix hydro, and then the root of the anion's name, and then you change the ending to ic, and then add the word acid. So HCl is hydrochloric acid. Hydrochloric acid. From the chloride ion, we change it to chloric and put the prefix hydro on it. Hydrochloric acid. Similarly, HBr would be hydrobromic acid. H2S, this one's got a little bit of a twist. Hydrosulfuric acid. We end up putting 2 syllables in there. But it's that pattern. Hydro, root of the anion name, ic, acid. The other broad category of acids that I want you to be familiar with are called oxyacids. These are sometimes also called ternary acids, and they involve our polyatomic ions with oxygen in them. Some examples of oxyacids: H2SO4, battery acid; HNO3, nitric acid. And so let's talk about how to name these. The name depends on the name of the polyatomic anion, so you need to have that identified before you figure out the name. We do not use the prefix hydro with our oxyacids. You have to look at the anion name. If the anion name ends in ate, the acid name will end in ic. Let's do an example. H2SO4, all right? The anion is sulfate, SO4, 2-. Okay, so since the anion ends in ate, the acid name will end in ic. So the name of this is sulfuric acid. Not all of our polyatomic ions, though, end in ate. If the polyatomic ion name ends in ite, the acid name will end in us. So, for example, H2SO3. All right, the anion is sulfite, SO3, 2-. And therefore, the name of the acid will end in us. And so the name of this acid is sulfurous acid. Let's do some practice. Let's write some names from formulas of acids. HClO4. Let's look at the anion. The anion is ClO4-. That's the perchlorate ion. 8 end in ic. So this is perchloric acid. HI. Oh, wait a minute. The polyatomic ion, there is no polyatomic ion. The anion is iodide. This is a binary acid. We use that hydro prefix. So the name of this is hydroiodic acid. HNO3. The anion is nitrate, NO3-. 8s go to ic. So this is nitric acid. Okay, this is doable. Let's write some names from formulas of acids. Chloric acid. Okay, so ics come from 8s. So I want this acid to involve the chlorate ion and the chlorate anion is ClO3 minus. So it would be HClO3. I need one H plus ion to write a neutral compound. Chlorous acid. Now, the us ending says I'm coming from the ite ion, so I need chlorite. And the chlorite ion is ClO2 minus, so chlorous acid is HClO2. Hydrocyanic acid. Oh, it's got that hydro prefix. That means it's a binary acid. Oh, well, not really. This is a pseudo-binary acid, but we're going to name it like it's a binary acid. Cyanic comes from cyanide, so it must be the acid containing cyanide. It would be HCN. And let's do oxalic acid. It comes from the oxalate ion. And oxalate is C2O4 2 minus. So I'm going to need two H pluses for that. H2C2O4 would be my acid. So it's really important that you know your polyatomic ions or are familiar with your polyatomic ions and can go look them up depending on what needs to happen for your class so that you can write acid names and formulas correctly. Let's summarize what we've done in this webcast. Acids contain H plus ions as the cations. That's how we're going to recognize them. We're going to name binary acids using that prefix hydro, change the ending to ic, add the word acid. We name oxyacids depending on the anion name. If the anion name ends in ate, we change the acid name to ic. If the anion name ends in ite, the ending for the acid is us. And of course, this works in the other direction. And this is how we name acids. So if you found this helpful, subscribe to my channel, learn chemistry every day, and leave a comment. Keep learning chemistry. That's the road to success.